Hey everybody, welcome back to yet another fun and exciting Algebra 2 class. Today we are going to be talking about a new concept. We're going to be kind of like adding on top of the concepts that we've already known from Algebra 1. This is a brand new concept. I don't think we touched this at all in Algebra 1. The idea starts off with the idea of going from a line to a plane. In other words, when you have two variables, you have a line. You have a point here and a point here, and you end up with a line between those 2 points. Okay? Now, when you add a third variable, you go from a line to a plane. A plane is like a piece of paper. Now, that's not a perfect example, but the true definition of a plane is that it has no thickness. So, in other words, a plane, geometrically speaking, doesn't have the thickness of a piece of paper. The plane is just flat and it's just the surface. There's no thickness to the plane. But for illustration's sake, a good example would be to think about a piece of paper. So if you can think about a piece of paper, when you put two pieces of paper together, they have a point of intersection. In fact, they have a lot of points of intersection. They have it's almost like a whole line, if you could think about like sliding two pieces of paper in so that they're touching. Then now think about adding a third piece of paper because we're going to be doing three equations. So lots of interesting things going on. If you will look in your book at page 236, you'll see some of these pictures, and that might help you also to kind of connect these things. Let me show you this. I was going to show you this. This is a website called Geogebra. I like the website. It's a great little website for finding different things. This is the idea of a plane. Okay, so here's a graph, and let me go back to this real quick. This is called Euclidean three-space. Euclidean three-space is kind of like a Cartesian plane, okay? Except now we're talking about three dimensions. So you have your x, let's say that green one is the x, the red one is the y, for example. I'm just, making examples. I'm not sure in this example which one's which. And then the blue one would be the z. We're going to add a z-axis, so x, y, and z. Well, here's what happens. You end up with a plane, and you can see that flat piece. It's almost like a flat piece of paper here. All right? Now, let's go ahead and go back over here, and let's talk about the three different types of equations that you can get when you're dealing with three variables. So three variable equations yield planes, not lines. That's what I wrote right there. Now let's talk about the three different types of systems that you can have. Now these are going to look very familiar to you. We can have an intersecting, C got a little crazy on me there. Let me try to fix that. Intersecting. Intersecting means they cross, so the planes can cross each other. You can have parallel planes. In other words, you could have two pieces of paper like this that never touch each other. And then you could have coincident planes. Well, what's coincident lines? One line right on top of the other. So you could have one piece of paper, one plane, right on top of the other plane. So the same things as with lines we're dealing with here with planes. Intersecting, parallel, and coincident. To be a solution, this is interesting right here. To be a solution, all three planes must intersect. All three planes must intersect. In other words, it's not a solution if only two pieces of paper are connected. The third piece of paper, so if you had two pieces of paper like this, and you had a third one just up here somewhere in space, kind of floating around, that would not be a solution. In other words, it would be a solution for these two planes, but it would be a no solution because this plane is not also. So if they give you a system with three equations, all three of them have to be touching. All three of them must intersect to be a solution. There are really, this is on page 237 in your book. There are really just two different kinds of solutions here. There are one point, so in other words, they only touch once, and then there are solutions that form one line. When you have a one-line solution, I want you to see this. Look at this. If you get one line, it's infinite solutions. In other words, the whole line, just like when you had two lines on top of each other, this is like three planes that are touching and they're forming a line. There's a picture of that in your book. You can take a look at that. But you can get, in other words, you can get different types of solutions here. You can get 1 point or you can get infinite points, and that is the three planes forming one line. All right, so that's a lot of like theory right there. That's a lot of different theory. So I want you to kind of have that background, that theory as we go into this question. So here's our first question. Our first question is x minus 3y plus 2z. I try to cross my z's here. I wouldn't do that if I was writing like in the alphabet, but I do it here in algebra so that you don't get confused between your 2 and your z. We're going to use a lot of z's here in the next few lessons, so you're going to see me use that cross there, just so you don't get confused. All right, equals 5. That's my first equation. Then you can see here my second equation. I won't read it, you can read. And then here is my third equation. Now, what we want to do here is we want to use the same principles, the same ideas, the same thoughts that we used when we were doing elimination. Now, here's the trick. We're going to take two of these and we're going to take them and we're going to work them separately. So let's take x minus 3y plus 2z equals 5 and the second one. So that's 2. I don't know why that doesn't say. I was sleeping here. That should be x, and that should be x. There we go. Sorry about that. And then our next equation is going to be 2x minus 4y plus 3z equals 8. Now, these ones take a long time to do. Now, the thing is, sometimes you can get scared because it's taking so long to do these, but they're not that bad. You just take them piece by piece and work through it. So what did we do first? Well, what we did first was we tried to find something that we could use to eliminate. And I mean, to me, I think the easiest thing that I see is if we multiply a negative 2 through this one, we will get that to be a negative 2 down here, and those will cancel. So let me go ahead and I'm going to just do it, and I'll put it down underneath. So I'm creating a new equation here. I'm actually not creating a new equation. I'm just multiplying the negative 2 through here. 6y minus 4z equals negative 10. Okay, so I just took the 2 times the x, the negative 2 times the negative 3, the negative 2 times the negative 2, and the negative 2 times the 5. And that gave me a new equation down there. I'm now done with this equation right now. Okay, so I'm done with that equation. I'm coming down here and I want to use these two new equations or the one new equation with the second equation from right here because I want to cancel something. I want to cancel that variable right there. All right, so we got that canceled. That's good. So now we're just going to combine the rest of these, and I'm going to get a 2y, and I am going to get a negative 1z equals, let's see, 2, negative 2. Okay? I can get rid of that 1z if you want to, or I could keep that. It doesn't matter. I kind of like to use it when I'm doing this because it helps me remember. All right, so now that has created a new equation. All right, so I got a new equation sitting there. We're just going to let him sit there for a second, okay? We're going to come back to him in just a minute. Now what we want to do is now we want to take two other ones. And I'm just going to take these two because it's easy. So I could also take 1 and 3. I could do that, okay? But I'm just going to take 2 and 3. There's a couple reasons I'm going to take 2 and 3. But I'm going to take 2 and 3. The biggest reason is so I don't have to write it again, okay? And then the other reason is because those two cancel immediately. Okay, so I want to just go ahead and cancel everything out here that I can cancel and add what I can add. Now this one's going to do something a little bit different, a little bit strange, but it's okay. That's going to cancel, and that's going to cancel. We have two that cancel, but that's fine. That's not a big deal. What I actually want is I actually kind of want my y term, so I'm going to put 0y, but that's fine. You'll see in a second what that does. And then I'm going to get a 1z, a positive 1z, and then here I'm going to get a 4, negative 4. All right, so there are my two new equations. All right, in other words, what I did was from both of these, from 1 and 2, I eliminated the x. And then from 2 and 3, I also eliminated the x. So I'm trying to eliminate x. That's my goal. Now what I want to do is I want to take these two new equations that I have, and I want to combine them together. I want to put them together because I want to cancel another letter. Because I can't solve it with two letters. I still have two letters, so I can't solve it. So I got to put them together again. So I'm going to bring this one over here, and that'll help me out. 2y minus 1z equals negative 2. Now this one is all set. Look at that right there. Perfect. That thing canceled itself. I love it. That helps us out. And so that cancels, and we get 2y, because we're adding, 2y equals negative 6. We're going to want to divide by 2, and we're going to get y equals negative 3. All right, so we have one of our variables solved. We got our negative 3. Now what do you think we might do? Well, like we did before, we have to enter that back in. Now here's the problem. You can't enter it back into one of the original ones. Why not? Because we only have one variable. We don't have two variables. So what you need to do is you need to enter it back into one of these that you already canceled the x on. So let's go ahead and enter it right there. And we'll just work that one down now. And so negative 3. So 2 times negative 3 minus 1z equals negative 2. 2 times negative 3, negative 6. Minus z, I'll get rid of that 1 now, equals negative 2. We're going to add 6 to both sides. It's going to cancel. We're going to get negative z equals positive 4. Divide both sides by negative 1 to get rid of that negative z, and we're going to end up with z equals negative 4. All right, so now we have our y and our z. We are still missing 1. We're still missing our x. So come back up here. Here's where you grab an original equation. Now you need the original equation because we're looking for the x. So let's go ahead and plug into that. So we'll plug into that original equation. That was x minus 3y plus 2z equals 5. All right, so now we're going to plug in our negative 3 there and our z there. So we're going to have x minus 3 times minus 3 plus 2 times minus 4 equals 5. All right, now let's try to get that x by itself, and let's see what happens. Let's follow our order of operation. We can multiply there, and we can multiply there. That's going to get us x plus, because that's a negative negative, and that's a 9. And then we multiply that out, and we're going to get negative 8 equals 5. So 9, we can just do this right here. 9 plus a negative 8, or 9 minus 8, is going to give us x plus 1 equals 5. We move that over to the other side. Minus 1, x is going to equal 4, positive 4. All right, so now let me show you how to write this. There we have our three answers. We have our x, there's our y, and there's our z. So let's go ahead and look at how we're going to write this. you would write it just like you would writing a normal x and y, except for now we're just going to add the z term. So we're going to have 4, comma. The y was -3 and the z was -4. All right. So now it looks like x, y, and z in our little parenthesis there. All right. And that's how you solve those, and that's how you would write those. Now, that took a little bit of time right there. These, you cannot solve these quickly. You cannot solve these very fast. You got to take your time, work through each step. If you struggled there to kind of follow me, go to a practice problem, watch the video, do each step as I do each step, and work through it and try to solve each one. So get it down, eliminate your x, eliminate your y, get your z. Or you can eliminate any one. You can eliminate your y and your z and you have your x left over, but the idea is eliminate 2, okay? Then plug back in. So plug the x back in, then plug the xy back in, and then you'll get all 3 of your solutions. And so there it is. That's what it looks like. 4, comma, -3, comma, -4. Okay, one more thing before I'm done. I need to tell you this because I am actually going to not teach the lesson on this. In the book, that it says that I can teach it if I want to, or if we need to skip it for time's sake, we can skip it. I'm going to skip it. Now, there's a certain reason why I'm skipping it, because all I need to do is teach you this one little part, and you have enough to do it when we get to it later. So I'm just going to teach you this one little section right here, and this is on page number 239. Page 239. It's part of this lesson, and in the next lesson, it keeps going. It expounds on this idea, but I need to show you this. It's called elementary row operations, ERO. Okay. Now, what ERO is ERO is like a shortcut. It will help save you time when you're solving these. In this chapter, the book is just going to ask you if you know how to do the ERO. Basically, do you know what ERO1 is? Do you know what ERO2 is? And do you know what ERO3 is? What they're asking you is, do you know these steps? Later in the book, we're actually going to use these, and that's when I'll teach it a little bit later when we get into these in a few lessons. Okay? So, what is ERO1? ERO1 is simply this, is exchanging EQ1. EQ stands for equation. Equation 1 and equation 2, you're just going to switch them. So if the book ever tells you, if a test ever tells you, if a quiz ever tells you, perform ERO1. Well, what is ERO1? ERO1, elementary row operation number 1, is just switching equation 1 and equation 2. It's the easiest question you can ever get asked in the history of the world, right there. So easy. Just switch 1 and 2. You don't have to do anything. There's no math. Just switch them. Okay? You're done. All right, ERO2. What if they say perform ERO2? What you have to do in ERO2 is you have to take it, and we did it already. We've already been doing this. You have to choose a number. That's why I put N right there. Choose a number to multiply times EQ1. In other words, what are you trying to do? You're trying to determine what do I need to multiply by so that I can cancel something. So this is ERO2, the second step of the elementary row operation, is multiply through so that you can cancel. Okay? And here it is. Here's ERO3, and here's the canceling. So you cancel with ERO1, and then you add it to, this is exactly what we've been doing. This is no different. We've already done this. Now we're just giving it a little cute little name. Okay? So we multiplied through, okay, we distributed whatever it was that we needed to, and now we're going to add it to equation 1, and that's going to cancel, and that's going to give us a new EQ2, a new equation 2. Mr. Steve, you're losing me. Okay, let me go show it to you, and I'm gonna remind you. I'm going to say we already did this. Okay, so let's go back up here. So when we did this, when we multiplied this, let me get rid of this right now real quick so you can see it. When I multiplied this by -2. That was an ERO2 right there. That was the second operation of the elementary row. I multiplied that -2 through there. What did that do? That created a brand new equation. Then what did I do? Then I did ERO3. What was ERO3? Well, I canceled out my x, okay, and then I got a new equation. That new equation, that is your EQ2 down here, okay? Your new EQ2. That's what you get when you cancel out by multiplying by a number. You cancel it out. That's right there in ERO3. You get the new equation. So really, I'm just kind of sharing some, I don't know, this is like jargon with you, if you know what jargon is. Jargon is like just some talk where I'm just sharing terms so that you know what it means. So later when the book says ERO2, you'll know what that means. That means you have to multiply through. If it says ERO1, you know that you have to trade those two equations. If it says perform ERO3, you know that you have to add those two to get a new equation. Okay? All right. Well, I hope I didn't confuse you too much there. If you missed anything, make sure you go back, rewind it, watch it again. And it's a long lesson. It's not a hard lesson, but it's a long lesson. So make sure you take your time on these, think through them, follow the steps that I showed you, and you will have great success, I know. All right. We'll see you later. You have a good one. Bye-bye.